This is the Smart Buildings Academy podcast with Phil Zito, episode 376. Hey folks, Phil Zito here, and welcome to episode 376 of the Smart Buildings Academy podcast. In this episode, we will be talking about server virtualization fundamentals. As always, everything will be available at podcast.smartbuildingsacademy.com/376. Once again, that is podcast.smartbuildingsacademy.com/376. As always, if you find this podcast valuable, please leave us a 5-star review on iTunes, subscribe, and hit the notification bell on YouTube, and or share this on LinkedIn. Thanks so much, everybody, for being here. And like I said, we're going to be discussing virtualization of servers in this episode. And this is a really important topic. And if you are not in building automation, if you're in access control, lighting, video surveillance, etc., this topic is going to apply to you nonetheless. So I encourage you to ask questions as we move along. I'm going to explain what server virtualization is. We're going to talk about the types of virtualization. We're going to talk about why we would virtualize, and then we're going to talk about how to virtualize. All right, so what is virtualization? I often like to call this a timeshare for servers. So if you think of a timeshare, you have a building and you get, or a room or whatever, and you get a certain amount of time each year that you're able to utilize. Well, a virtualized server, in our case, and you could do virtualization for many other things, but a virtualized server is going to allow us to split our resources between what are called instances, and I'll define what instances are in just a little bit. It's going to allow for scalability, and it's going to enable redundancy. So virtualization, essentially what you do is you have a computer, and that computer has memory, storage, and computing power. Those are the three primary resources of a computer: memory, storage, and computing power. And when you have those resources, you are able to go and take those resources, and you're able to essentially slice them up and share them amongst what are called instances. And these instances, or virtual machines, and virtual instances on a virtual machine, are essentially standalone, isolated operating systems, maybe Microsoft Windows, maybe Ubuntu Linux, maybe Windows Server, etc. But they are running, and they're taking a portion of the memory, CPU, and storage of the device that they're on. Now, why would you want to do this? Why not just put it on a server? Well, for a lot of what we do in building automation, we don't need a full-blown server, for one. If you go to a catalog sheet on most building automation software and you look up the recommended hardware requirements, that's still much less than what most dedicated one rack unit servers contain. Most servers these days can easily run multiple instances of building automation software. Also, by virtualizing, what we are getting is we are getting the ability to have scalability. So what often happens is when you run a virtual machine, that virtual machine is going to run in a pool, and that pool is going to draw the memory, storage, and compute that it needs on a case-by-case basis. So if you have a virtual server and you decide to add 4 buildings each with 4 supervisory devices, you may need to increase your memory. Maybe you need to increase your compute because you have multiple people connecting to that web server. Well, what can now happen is, with that scalability, you're going to be able to go and you're going to be able to ramp up that scalability as needed. So if you need to go and increase memory, you need to increase storage on the fly, you can do that. That's called elasticity. That's the technical term for what we're doing here. It also enables redundancy. I was talking with a gentleman this morning about some of the challenges that building operators face and how they have these physical machines, and maybe a physical machine goes down for whatever reason, cyber attack, maybe physical failure, whatever. By having a physical machine, well, guess what you have to do? You have to replace it with another physical machine. In a critical environment, that could result in downtime. Whereas with virtualization, if you have a virtual image of that machine, then even if you have a physical machine, you don't have to reinstall everything. You could put a new physical machine in and you could download that virtual image. If you're using a virtualized server in your data center, then even better, because now what you can do is you can actually take that virtualized image and just roll it over to another machine in the data center. And if you've got things set up right, you'll never even notice that the machine went offline. So redundancy is a big capability of virtualization. The final benefit of virtualization, and we'll talk about this in greater detail and why virtualize, but is the ability to rapidly deploy building automation server software and images. Once you've created an image, you can deploy it to multiple machines. And so you can stand up servers quickly. It can really reduce time, which right now, time is a huge resource that a lot of building automation contractors and operators do not have. So what are the types of virtualization? There's type 1 and type 2. We use primarily type 2 hypervisors. Hypervisor being essentially, for lack of a better word, the software that runs the virtualization. We use primarily type 2, but there is type 1. Type 1 is what's called bare metal hypervisor. Essentially what it is you have a rack, one rack unit. So it would essentially take up one rack unit, which is about 4 inches on a rack. And it's a server. And this server has no operating system software. It just runs this hypervisor, which then enables it to manage VM instances, virtual machine instances on this virtual machine hypervisor. It's high tech, utilized by a lot of organizations, pretty low key. If you're in a Fortune 500 business or something like that, most likely if they deploy a virtual machine, it's on a type 1 hypervisor. For the rest of us, we use what are called type 2 hypervisors. This is what most of the folks listening to this episode are probably familiar with. And this is where we have maybe VMware, the virtual Oracle VirtualBox, etc. And we have an image, and the VM software sits on our operating system, and it runs just like any application would run. And it allows us to allocate a certain portion of that machine's resources to our virtual machines. So pretty straightforward so far, I hope. If you have any questions so far, let me know. Hopefully this is all making sense. And then we have number 3, which is what I call kind of like a cloud. It's basically cloud, but it could be private cloud or it could be public cloud. So it could be your own private data center, in which case it would just most likely be a type 1 hypervisor. Or if you're using Azure or maybe you're using AWS, you could be running a virtual machine on their type 1 hypervisors in their cloud. And you would just essentially stand up an instance, create a virtual network connection or virtual private network connection, and connect it to your supervisory devices. So why go through all this effort? Why would we want to do this? The biggest reason right away is going to be reliability and uptime. If you have a critical environment, you should definitely consider virtualization. The reason why is the ability to have an image that you can roll back to at any point in time is super powerful. You essentially, an image or a snapshot of the virtual machine is recorded. It's ideally stored in multiple locations. And then if that machine goes down for whatever reason, you can bring up that image and that image will enable you to keep running. You can actually have failover virtual machines. So there's essentially a heartbeat code, and if one of the virtual machines in the cluster goes down, the other one kicks on, and they're maintaining a constant image. And essentially, it's like the system never failed. So it really gives you a lot of uptime and reliability. Additionally, one thing I didn't mention earlier is the level of effort. For a lot of building automation contractors, they are really stretched thin when it comes to technical staff right now. It just is the reality. And then if you add in IT technical details into the mix, you get an even smaller pool of talent. So by not having to potentially stand up a physical server, get it all set up, but rather just having to install your software on a virtual image that's maintained by an IT group, that makes your life a lot easier. As I mentioned, we have the ability to roll back. So we can roll back to a previous image, and that really helps us out a lot. And then finally, we have the scaling of the resources, the ability to have that elasticity that enables us to scale depending on how much we need to go and have as far as resources are concerned. So CPU, storage, and memory. So how do we virtualize? How do we approach this? It's actually pretty simple. This is going to be a pretty short episode unless people have questions. So let's talk through how we virtualize. First things first, we have to choose our VM platform. Sometimes this is chosen for us. In the case of most customers, they will go and have a type 1 hypervisor, and they will say, hey, this is the type 1 hypervisor. It's tell me what you need as far as your hardware requirements. You'll tell them I need this many cores at this speed, this many gigabytes of memory, this many gigs or terabytes of storage, and they will go and they will stand up an instance on their type 1. If you do not have that, then often you will have a server that you will go and potentially install a VMware instance on, and you or an Oracle, VirtualBox, whatever, you'll stand it up, and then you will go and you will stand up an instance based on what you need, like how many CPU do you need, how much memory do you need, how much storage do you need. You will get this from your server catalog sheet. So you're building automation, access control server, whatever, you will get the requirements from there. Then you create the instance, which really in most cases is very simple. You just click new virtual machine, select your memory, select your storage, select your CPU cores that are allocated, and then you go and you select what type of OS you're going to install. You grab a ISO file, and that ISO file is typically on a network share or on your desktop. And you link to that ISO file, you boot the virtual machine, and it's basically just like installing Windows or Linux from scratch. Once it's fully installed, once you've installed all your supporting BAS software, access controller, lighting software, whatever you're doing, then you create a snapshot of that image. And then moving forward, anytime you upgrade that software, upgrade that server, do anything, you create a snapshot. And you can also create snapshots on a regular basis, and then you can roll back to a snapshot if needed. Another path for virtualization is the exact same, right? Choose your VM platform, understand your requirements, create the virtual machine instance. But then instead of a OS operating system ISO file, you're going to go and actually use a ISO file of the image. So you're going to use an image file. Actually, it wouldn't be an ISO file, it'd be an image file. And you're going to link to that image file and boot that up. And guess what? It's going to be a pre-configured server for whatever software you're running. So there you have it, folks. That is server virtualization in a nutshell. Pretty straightforward, pretty simple topic, but a very poorly understood topic by a lot of folks. And so I hope that this topic clarified things for you and made things make more sense for you. If you have any questions, do not hesitate to reach out. Let me know whatever I can answer for you in regards to questions. I will definitely go and do. And until next time, folks, I'll see if I have any questions. But if I don't, we will just go and call it a day. Let me see. All right, we're looking good there. Everything's looking good there. Let's see if we got any questions in chat. Not getting any questions in chat. Okay, that makes life pretty easy. Let's see, what is that? Here we go. Okay. Well then, folks, no questions on servers. So I'll give it about 15 seconds to see if there's any questions. Otherwise, like I said, this is going to be a short one. I do want to let you know, we have about 30 guest podcast interviews coming up. We're doing the pre-calls with all the guests, and we're really striving to moving forward, having Monday and Friday be guest interviews. I think that it'll bring a lot of insight as we draw people to the podcast. And then Wednesdays will be our topical podcast where we'll teach on something. So if you have an idea for a guest, let us know. If you have an idea for a topic, let us know. And as I say always, please do not hesitate to like and subscribe. And or leave us a 5-star review on iTunes. Those are greatly appreciated. They really help spread the podcast to other people. And, I really personally appreciate that. Thanks so much. And if there's, happy Halloween to everyone. Totally forgot. Hopefully you all have a great Halloween. Hopefully you all really just enjoy today. Get a lot of candy. I'm sure my wife won't let me eat the candy because I need to keep losing weight, but it's just the curse of liking food, I guess it is. So, but you all eat candy for me and tell me how good the candy tastes. Maybe take pictures, post them on LinkedIn and tag me and be like, Phil, the Snickers is delicious. It's too bad you can't have one. So anywhere else we can leave you a review other than iTunes. We're on Spotify, we're on Stitcher, we're on all those places. So I'm sure you can leave us one there. YouTube, like us, subscribe, hit the notification bell. So yeah, that's kind of it. iTunes is the 800-pound gorilla in regards to podcast. But I will tell you, folks, I'm super excited about the guests we have coming up. I mean, we're going to talk about some wild stuff. It's going to be a lot of fun. I'm going to ask them questions that they haven't been asked in the podcast that they've been on. And we're going to dive deep into some real problems that the industry is facing and actually see if we can figure out how to solve some of them, maybe. I mean, maybe that's a little presumptuous to think that we could solve stuff, but who knows? Maybe we can. Alrighty. Anybody got any questions? Last call for questions before I close out the podcast and go eat lunch. So I'll give you all about 15 seconds since I know there's no latency on YouTube. I noticed it's like, boom, done. But there is some on LinkedIn, I noticed. So, all right. Not seeing anything. Thank you so much. Everyone have a great Halloween if you celebrate that in the country you're in. Thanks so much for being here, and I'll talk to y'all on Wednesday. Take care, everybody.